All right, let's dive in. Today, we're breaking down all the awesome stuff from day one of the Google and Kaggle course on building AI agents. We're going to cover the absolute essentials you need to know to go from just writing a simple prompt to actually commanding a whole team of intelligent agents. So, here's our game plan. We'll kick things off by figuring out what really separates an agent from a regular old chatbot. Then we're going to build one, see how to scale that up to a team of specialists, and wrap up by exploring three super powerful ways to make them work together: the assembly line, the parallel task force, and the refinement loop. Okay, let's start with the most important idea of the day. To really get what agents are all about, you've got to think beyond the simple back and forth of a chatbot. We're stepping into something way more active and, honestly, way more powerful. So, what is an AI agent? Well, at its heart, it's an AI that can think for itself, take actions in the real world, like, searching Google or running a piece of code, and then it can observe what happened. It looks at the results of its own actions to figure out what to do next. That ability to do stuff is the absolute game changer. And this slide just lays it out perfectly, doesn't it? Look at the left. A standard LLM is a straight line. You give it a prompt, it spits out some text. End of story. But on the right, the agent has this loop. It thinks, it acts, it observes, and it can go around that loop as many times as it needs to. It's the difference between a passive response and active problem solving. Moving on, now that we've got a handle on what an agent is, let's get into what one is actually made of. And you know what? You're probably going to be surprised by how simple the core parts really are. Building a basic agent really just boils down to these four things. You give it a name, just so you know what to call it. You pick a model, which is basically its brain, like Gemini. You write an instruction, which tells it its job and its personality. And this is the most important part, you give it a set of tools. These are the actions it's allowed to take. And check this out. This is a perfect example of an agent doing its thing. This quote on the slide, this isn't just something someone typed up. This is the actual output from an agent built in the course. When it was asked about the agent development kit, it didn't just guess based on old data. Nope, it used its Google search tool, found up-to-date info, and put together this accurate answer. It took an action, and that's everything. Okay, so a single agent with a tool, super powerful. But what happens when your job gets, really complicated? This is where we graduate from having one single worker to having a whole coordinated team. And this is the exact problem we're trying to solve. I mean, think about it. If you try to build one super agent that has to do everything, research, write, edit, code, fact check, its instructions become this giant tangled mess. It gets confused, it's unreliable, and trying to fix it is a total nightmare. And here's the elegant solution. Instead of one monster do-it-all agent, we build a multi-agent system. It's just like building a team in the real world, right? You get a bunch of simple, specialized agents, and each one has exactly one clear job. This makes the whole system so much easier to build, to test, and in the end, it's just way more reliable. So how do we get these specialist agents to work together? Well, the first and most direct method is what the course calls the assembly line pattern, and it's built using something called the sequential agent. The idea here is really simple, but incredibly useful. A sequential agent runs your team of agents in a strict, predictable order. The work from agent number 1 gets passed automatically to agent number 2, and so on down the line. It's a clean, reliable pipeline. So when do you use this? You use it when the order of operations is non-negotiable. The example here is perfect. You absolutely cannot have an editor agent start working before the writer agent has even written anything. It's just a logical, step-by-step process. The assembly line is great, but it's not always the fastest. Sometimes it creates a bottleneck if certain jobs could actually be done at the same time. And that brings us to our second pattern, which is all about speed and efficiency. The parallel agent is exactly what it sounds like. It lets loose a team of agents to all work on their tasks at the exact same time. It's an amazing choice for jobs that don't depend on each other, and it can give you a massive speed boost. The perfect use case is when you've got independent streams of work that need to get done. Imagine you need research on tech, health, and finance. Well, the health researcher shouldn't have to sit around waiting for the tech researcher to finish. You can run them all in parallel, and then once they're all done, you have a final aggregator agent that combines all their findings into one report. Okay, so our first two patterns run from start to finish, and then they stop. But what about tasks that need feedback? What about getting something from a first draft to a final, polished version? For that, we need our last and most advanced pattern, the refinement loop. A loop agent is what lets a system actually improve its own work. It runs a cycle of agents, say a writer and a critic, over and over again until some kind of quality standard is met. This is where we get into iteration and self-correction, and it is seriously cool. This is your go-to pattern for when good enough on the first try just isn't going to cut it. The classic example is a writer agent creates a draft, a critic agent gives it feedback, and then a refiner agent actually implements those changes. And that cycle can continue again and again until the critic agent finally says, yep, this is perfect, we're done. So let's put it all together. Think of this table as your little cheat sheet. If you need this system to decide what to do on the fly, you use that basic LLM-based agent. If the order of operations is everything, go sequential. If you need raw speed on independent jobs, it's parallel all the way. And if you need quality through feedback and refinement, the loop pattern is your best friend. These are the fundamental patterns for getting your agents to work together. And that's a wrap on the big ideas from day one. We've gone from a single agent that can take actions all the way to orchestrating teams in these sequential, parallel, and iterative workflows. The building blocks are actually pretty straightforward, but what you can build with them is just enormous. So that really just leaves one question to think about. Now that you know how to do this, what's the first problem you're going to solve?